Today we're going to start off by, let's go over Wallaby Bob number 5. Crocodile number 5. We're on crocodile number 5. So on crocodile number 5, a water tank is in the shape of a hemisphere. Hemisphere meaning half of a sphere, right? As shown in the diagram below. The water is being pumped into the tank at a rate of 45 pi divided by 2, a very suspicious number there. 45 pi divided by 2.
All right.
That is a very suspicious.
So water is going in here by this rate, and this is what the water, oh my gosh.
Oh my
Goodness.
gosh.
I can do better.
Okay, so water's being pumped in here. This is the water here. Okay, so at that rate, what volume of water will the tank hold when it's full?
The radius is 10 feet.
The radius is 10 feet, correct?
It's drawn on the thing.
So therefore, the volume of the entire sphere, right, Carson, would be what?
To be quite honest, I zoned out.
You looked a little zoned out when I picked on you. The volume is equal to what in a sphere?
A sphere?
Yes.
It's
4/3?
pi cubed over 3.
3/4?
Pi
Cubed
r
over
cubed
3.
I know that part.
4 over 3.
That's close enough.
Okay, all right. So this is, if it was a full sphere, I would get that, but it's a hemisphere. So it's going to be 2 instead of 4. Then you put in the 10, right?
Oh, no.
So it's going to be 2,000 pi divided by 3, right? When it's completely full, that's what you're going to get. How long will it take to fill the tank?
I wonder.
Well, you're given the rate.
Don't you just
This how much goes? This goes in how much? How often? Per minute. So it's cubic feet per minute. That's the rate. So what do I need to do?
Divide it.
Divide it, right? Just divide it out. I would divide this by 45 pi divided by 2.
I'm on top of it. Come on, man.
Okay.
And what would that be?
So we would get rid of the pi's first. This is the same as 2,345, 2. Whatever that may be, right? We
I'd
can go
say-
through that. I'll leave that up to you guys. Okay, so that's what you're going to get. C, here's the $64 million question. How fast is the water level rising when the water is 5 feet deep in the center? Okay, so this is the question that we really want to know. Okay. So when it's, let's kind of see if I can draw it at 5, better, about 5 right there, right? About 5. Okay. So we have to come up with an expression here that somehow ties the V and the H. Okay, H is being given to us as this guy here, right? H, right? We have to tie this guy with this guy, right? And actually, for your convenience, it's given to us, right? You may assume and use this formula.
Will you do that?
Well,
Will you do that?
huh?
Will you give us this?
Will you give us?
Will I give you this? Yes, I will give you this.
Oh, okay.
If I were to give this question to you guys.
That is not the one.
Okay, so V is equal to what?
Pi.
Pi
Height
h
squared.
Pi h squared
3r minus h
3r minus h
over 3. All
over 3. Okay. So really, if I rewrote this, I get
No. Don't do it.
r is nothing but a constant,
Mm-hmm.
correct?
So is h.
Minus h cubed, but actually it's not a constant, is it? What is r?
It's fine.
It changes.
Wait.
R is
R
10.
changes.
R
It
is
changes.
10.
Is r 10 all the time?
Yes.
No, it is not.
The radius of the sphere will always be 10.
I don't know. The line
It
looks
doesn't
a
look
little
like
bit
it's eating.
shorter.
So let's pick this point here, okay? Let's pick
No,
this
look.
point
You
here.
draw a straight line out there.
Okay.
A little bit.
So this point here is on what? It's on this graph, correct?
Hmm.
Isn't it on this graph? And this is a what?
Circle.
It's a circle with the center being, if I call this your x-axis and my y-axis is like this, right? Where's my center?
Y.
0 and 10, correct? Okay, so it's 0 and 10. So then the equation that I would play with would be
5, 12, 13. You take a root.
X squared plus
You take the root.
y minus 10 squared is equal to 100. You see that?
Yes.
Yeah.
Right? Because I moved it up 10, correct? I moved it up, so where y is, I put y minus 10, right? Okay, so, and this is going to be what?
I'd say
5. I would say 5.
5, 8.
No, I would say 10.
What?
10.
No, this here
Oh,
is
that
10,
is 10.
right?
Oh.
This here is 10,
And
right?
5.
5.
So what's this?
I don't know.
I'm
Did you
somehow,
draw a
I'm going to
square?
have to know this.
That is
I have
10.
a feeling. That is 10.
Right?
That is 10.
Yeah,
Correct.
because it goes
This
to the
is
other side.
H.
Which is
What is this guy here?
5.
Didn't you say it's 5?
No.
Yeah, because it gave us.
No, okay,
It's
again,
10 minus
again, we're
H.
looking for
10
just
minus H.
10 minus H, right? It's 10 minus H? Because this is H.
Correct.
Which we know is 5.
Well, we will evaluate that at that point, right? Okay. So again, so we have this, so which means that this guy here is going to be what?
Probably.
I don't know. You did the whole equation.
So we know what y is, right? Where are we at? What's happening? What do I
10
do?
minus
We're
h
given
squared
We're
plus
designing
x
H.
squared equals 100.
So this guy here is going to be what? If I call this, well, it's going to be on this guy, right? We know that, right? And x is equal to, y is equal to what here? Isn't y equal to h right now?
Yeah.
Yeah.
So it's fine.
H, right? So this here is h, which means that x is equal to what? Can we find an expression for x here?
Wait, where is X? X is the orange dotted one?
Yeah, from here to here is x, right? No?
10 minus h squared plus something squared. Wouldn't it be x squared equals 100 minus 10 minus h squared?
R and H. R and H. R and H. Oh,
I was right. It is the radius.
R and H. Okay. All right. So if this is R, how is that R? I don't see how that's R.
Yeah, I do neither. That's what I.
The distance from here to here, right?
Is R.
This is 0, 10. Correct?
The distance from there to there would be r, wouldn't it?
So what we're calling this is r squared plus h squared is equal to 100. Okay, that is this line, right? This is this right here, the equation for this. Okay, so what we're saying that is that when the distance between this and this is going to be what? R minus 0 squared plus h minus 10 squared, and that's going to be equal to 100. Does that make sense? Because the radius has to be 10. And now you take the derivative.
But we already had that up there.
Zero. 2's go away.
Wait, don't you, do you multiply?
Huh?
Do you multiply something by 10? Don't you have to take the chain rule of inside the h minus 10 or not?
We did.
Where?
And that's dh dt.
Oh, okay.
Because if I take the derivative, this guy goes away, right?
Oh, yeah, okay.
Right.
Yep.
Okay.
Oh, that's.
So what we're trying to find is the ratio between dr and dh, dt and dr dt. What?
He didn't know that.
He didn't know
the h prime.
DHDT meant H prime.
What
I just assumed it was just some. I just thought it was something like. I didn't know what it was. I thought it was just a thing that you.
Okay, that's all right. That's all right. That's
I
all
just
right.
figured that
But
out.
what we do, we know it now, right?
Some of us learn slower.
We know
than others.
it now, right?
2 months.
Okay. So at the point where h is equal to 5, what's happening here? When h is equal to 5, what do we got?
What? When h is equal to 5.
H is equal to 5, we have what? 10? This is 10, right?
Fine.
And we have minus 5 dt.
Mhm.
Can you divide it by?
Hang on a second. H equal to 5, 5,
How is 100 plus
25, so it's going to be not that. 75. R squared is equal to 75. R is equal to 5 root 3. 5 root 3.
Oh, because the triangle
Because the
is
triangle, yes.
x 2x, x root 3.
Correct.
Oh.
What?
1,
triangle?
2 root 3.
Let's go. Okay.
Right? 5, 10, 5 root 3.
What is
Okay.
this rule that you keep saying?
Pythagorean.
But how? Why?
60, 30, 90.
Oh,
But
question.
you don't know the angle.
Where did you get, did you do the top, like we don't know what the radius is? The thing you just did, not the, like where you got the 5 root 3 equation wise up there?
Up here.
But like why is it, we are solving for r, that's why you don't plug in r is
Yeah.
equal to 10?
Yeah.
Okay, okay.
So you're going to move this over.
Mm-hmm.
Root 3 dr dt is equal to dh dt. Are we good?
Mm-hmm.
Just
What were we looking for here?
We're looking for this right here. We're looking for the relationship between dr dt and dh dt. Because we're going to get both of those when we take the derivatives here, right? So I want to be able to put it into 1, right? Because we're looking for what? We're not looking for dr dt. We're looking for, what's the question?
DV.
dv,
No.
Yes.
d,
How fast is the water level rising?
That would be the
That would be dh dt, wouldn't it?
oh yeah, 'cause it's
The water level rising here, the water level rising, right?
Yeah,
dh dt.
right, 'cause it's the level.
Okay, so it's dh dt, right? So we want to know this in the end, right? So we have to solve for dr dt, and dr dt is equal to 1 over root 3 dh dt. Okay.
Why are you solving for dr dt?
Because I will get dr dt's here. I'm just, well, let me go forward. If I go forward, maybe it becomes a little easier. So if I take the derivative of this, what do I get? dv dt is equal to pi over 3. What do I have here? I have the product rule. dr dt, consider this small r. And then we have, I leave this to take the derivative of this, so it could be 6r h dh
Wait,
dt.
why didn't you multiply that by
What did I what?
multiply it by h squared?
I mean, this guy is changing also. This is a variable too. So I left the 3r.
Well, you didn't. You took the derivative of
Yeah, it's a 3r, and then I take the derivative of h, so I get 2, right?
Right, but wouldn't it be 3 dr dt times h squared?
Minus.
I'm talking about this one or talking about this one?
No,
Oh, this one. Oh, it's
first
h squared.
H
H squared. Yeah, h squared. I'm sorry. My bad.
Plus.
Okay, over here, then you have
Yeah,
3r times 2,
Uh-huh.
oh, so it's a derivative.
which is the 6r,
Yeah.
h dh dt.
Okay.
And then you have this guy,
Wait, why are you
minus
talking about
3 h squared
Why do
dh.
you have H and DHT?
No, we did that with the y's, where you had to like
I'm doing the
leave it
chain rule.
with the number, and then you also had to take it out.
The chain rule, right?
Oh, so you,
Because there were two of them.
oh, code, so it's 3h and then inside of it.
Because there's still an eight.
Pi
There's
over
still an
3, 3. Now I know this. So I write here, I'm going to put this guy in. Okay, this is why we solve for dr dt. Okay?
H. Wait, what is that whole thing after that?
This guy here?
Yeah.
Derivative of this guy.
We hadn't even done that yet?
No, we haven't done that yet. Well, you still have to do it.
Minus, okay, slow down. Minus 3h dh dt.
3H squared.
Then what?
That's not what it says.
This is bad.
That's all that has.
Which one did he tell us to know?
I did that for one. I don't even know. I never know how to do it, but we did big class.
h dh dt minus 3h squared dh dt. Okay?
Okay.
So let's go ahead and pull out the
Written down.
dt's. Pi over 3 dh dt. I'm going to pull out all, so I'm going to get rid of this
Where
guy,
did the root 3 come
this
from?
guy,
Mr. Ron,
and this guy right
That.
here.
where'd the root 3?
Right here.
Because he's times by
Because the first time we just found.
Okay, so then you replaced it with a dh dt.
Mhm.
Then you went.
So this guy's going to be what? Root 3 times h
Why isn't it
25.
3 root 3?
H is 5.
Why not?
Now I'm going to
3
put in the
root 3?
5.
Where did the 3 go?
3 divided by root 3 is root 3.
Huh?
I guess so.
Because root 3 times root 3 is 3.
Alright,
We get to 25? We
Yeah.
get to 25?
where'd that come from?
Because the 5 is
H
the
squared
Okay.
plus 6 times r was 5 root 3. H was 5.
Not 10, even though it gave it to us as
No, that's the,
No, that's a different r.
different.
yeah,
Oh.
that's the R.
That's a different R. Got it.
Minus
I
3
did the
times
page. No,
25.
this one?
No, she's
Wow.
not.
No, I'll figure that out later.
3 times. Well, this is interesting. 3.
3 times
So
25,
25
75. I know the
root
last
3.
one.
I feel like he's making it more
25 root
complicated than it
3.
has to be.
Are we good?
Yeah, let's
150
keep
root
going.
3.
Keep going.
175 root 3 minus 7.
How many root 3s do we have
We
here?
have
We have
2.
25. Over here we have 5 times 5, which is 25,
Times
times
6.
6, which is 150. So I have 175 of them, right?
Minus.
Uh-huh.
175 root 3 minus 75.
I'm just hoping now.
Look at how much writing you have.
Okay?
Uh-huh.
Uh-huh. Now let's
Now what?
Why wouldn't we
put
just
the pi over 3 back in there.
Now,
Oh.
we know that this is equal to dv dt.
we
What is
know.
We know dV/dt is
The volume.
45 pi.
45
No,
pi
over 2.
Okay.
over 2.
Alrighty.
These cancel out. What am I trying to find? I'm trying to find dH/dt, right?
Can you just
You are. So you times by 3 and then divide by 175.
Oh yeah, okay. Times by 3, which is 135.
dH/dt is equal to 45 divided by 2. And this guy goes all underneath the bottom.
Yep.
175 root 3 minus 75
over 3.
over 3.
Wow.
Okay.
Oh,
Nice.
so then it's
Not too bad.
And if you do this, you get about 0.3.
Alright.
Yes.
0.2959.
9.
Alright, no more.
So why was this hard?
there's so many steps you have to remember them all.
Well, you had to get the relationship between drdt and dH/dt, right? That was the hard part.
I'd say so.
Okay, that was the hard part. To me, that would have been the hard part. I do not want to do that one.
I think that's enough for the day.
Yeah, we're doing this.
Okay, so let's move back to your book. Now let's go to the book
What?
and see if we can go to the
Mr.
book.
Mr. On. I know
I
it's
didn't bring
mine.
mine.
Oh. You can use mine, Abby. I'm not there
I
yet.
figured we were doing all of them.
5.6 related rates.
We're supposed to do them all, but there's stuff in the book that this is. You didn't want to see
Page
the book.
252, example number 1. We did example number 1.
That's what all this has been?
Look at example number 1.
Oh my gosh, I remember.
You remember this one, right? This was
Yes.
in the Wallaby Bob.
Mm-hmm.
Let's go to example number 2. This one we did not do.
No, but
Not that hard though.
we
Let's
did
go to
the-
example number 3. We did not do that one. We did something close to this. We had
We had the boats.
ships sailing one way or the other and whatever, right?
Mhm.
Okay, so this should be okay for you. Example number 4. We did example number 4.
Mm-hmm.
Filling the conical tank.
I don't like that one.
Oh, you don't?
I don't
Thank you for
I don't
letting
understand
that
how
know.
to do that.
Flip the page, and then that's it. Go to your homework. If you go to the homework, let's look at number 11, page 257. Number 11, we did that.
We did?
Read it. Should feel
Balloon
familiar,
Radius increasing. Yeah.
right? We did
It's
that.
just the volume of the sphere.
12 is the same thing, so we did that. Go flip the page. Okay, so look at number 20. That look familiar?
Yeah.
Should look familiar, right?
I just wanted to-
Number 21, we did that. Remember number 21?
I
Mhm.
think I
Pulling the boat in, remember pulling the dinghy in, we did that one. We just did number 18. Okay, we did that one. Okay.
We
What-
did number 19.
The ones that we didn't do that I think that we should do is, they don't have a swimming pool here?
I thought we did a swimming pool one.
We did-
Volume?
Yeah, you guys did do a swimming pool.
We did a filling up swimming pool.
We did the swimming pool, right?
Yeah, we did that in the packet.
We didn't do a plane.
No plane.
Okay. So as far as I'm concerned, we did most of the stuff that we needed to do. There's one thing that we did not do, and that is the pressure of a plate when placed underneath the water.
Oh, you're
Okay,
not
we
gonna
didn't
do
do that one.
Airs back there.
I'm gonna let you guys figure that out once you go to college.
Oh,
Oh,
sounds
okay.
good. I thought you were gonna stay on our own. Alright.
That's really nice of you,
So you
Mr.
guys
On.
figure that out. I mean, you guys are gonna have to know how to do it, especially, well,
Lily, are you
engineers or anything like that or whatever.
No, I'm studying the
okay?
brain.
Okay, so yeah.
It's like, what